Hey guys, I'm going to show you how to make an electrochemical cell that makes sodium hydroxide. Like I said I was going to show you, it's just kind of like a cool, easy experiment that you can do, and it's relatively simple to do, and I'm going to show you exactly how to do that. First thing that you're going to need is you're going to need a sodium chloride solution. So you just go to any store and you go get any type of salt. You typically want to get salt that's pure sodium chloride. You don't really want any contaminants. The one that I got was a sodium chloride, sodium silicoaluminate solution. But the good thing was that the silicoaluminate was insoluble in water, so I dissolved it in water and filtered it off. So you can do that just so you can get a pure solution. A little bit of that stuff won't hurt it that much, but you don't want to have a high concentration of it because it can interfere with the electrolysis process. You're also going to need some electrical twine that you can go buy at any hardware store. It looks like this. And what you're going to do is that you're going to take two strands off, like that looks like this. Take two of those off, and you're going to apply it to a plug-in. You're going to plug into an AC plug-in, look something like this. Plug it here. Look something like this that you can plug into any wall. Make sure that when you look for one, it has a double-stranded like that, so you can split it apart. So you can control which one goes in and which one goes out. You can use a solid one, but it's a lot harder to figure out which cord is which. I would suggest using something like this. You don't have to buy one. I use one from a scrap computer box that we had, and you can use that and all that stuff. Here, you don't really need an extension cord, but you will need an outlet to plug it in. So you just plug that in like that. Okay, that's plugged in. Sorry about the quality of this video. And then you're going to take the end, which is this right here. I took the end off of that cord and I cut it off, and you're going to split it apart into something like this. You split it apart, and what you're going to do is that you're going to take this black wire and you're going to strip off the covering. You're going to take up the covering to where it can expose just the wires inside. Alright, and then after you do that, you're going to take your individual strands of copper and you're going to wrap it around this like that. You're going to do it multiple times to make sure that it is a good connection. The last thing that you're going to need, it's kind of an important thing, you're going to need a source of graphite or carbon. I use basic pencil lead that you can buy at any like Target or Vons or whatever store that's nearby that you can get office supplies. I would suggest getting the thicker stuff, because the thicker the better, because I'm going to explain why in a minute. You can also get really thick ones from really big bulky batteries that you use in giant lights to light up everything. But I use this since that's all I had on hand. So this is what's going on here. You're going to take the copper wire, as you see right there, and you're going to wrap it around one of these graphite electrodes, because graphite will not interfere with the reaction. It acts as like a spot for the reaction to occur. So you're going to do it on both sides. I will explain what's happening here in a minute. So you're going to wrap it around the copper wire and you're going to put it into your solution and you're going to plug it in. It won't hurt it to plug it in, but I would suggest doing very small scale to make sure that your electrical outlets will use it. This battery pack does get a little hot every once in a while, so you might want to unplug it and give it a break. So with that being said, this is what's happening. I'm going to explain what's happening right here. This is the positive electrode and this is the negative electrode. So what's happening here is that the electricity is reacting with the sodium chloride in the water, and the positive electrode right here, the positive electrode, it's splitting the ionized salt and it's attracting the chlorine to this one, the chlorine right here. And so what's happening is that two chlorine molecules are going to react with each other. They're going to be anions, single anions, and they're going to create chlorine gas, or Cl2, and 2 electrons. And that's what's coming off right here. You'll be able to smell it. Be careful around chlorine gas because it is a little toxic to breathe. Small amounts of it will not hurt you, but it's just to make sure you know what's going on. You can use sodium carbonate or any type of sodium salt that works for you, because it's going to produce gases and sodium hydroxide. So anyway, that releases chlorine gas, which does erode the electrode a little bit. As you can see, the flakes are breaking off. That's why you want to have a lot of this stuff, or you can get a really thick one to keep it together. So you can do it like that, or however you float your boat. You don't want to have the copper in it because the copper will react to make copper hydroxide, which is what you don't want. Here is the negative electrode, and this is where the water and the sodium cations are going to be attracted to. So the two molecules of water, what's going on here, is going to be split apart into 4 hydrogen, 4 hydrogen cations, and it's going to shift, and it's going to create hydrogen gas, which that's going to release 4 electrons. And it also, what's going on here is that the hydroxide molecules are breaking apart, and that's what's only being left over. So the hydrogen positive ones are reacting to create hydrogen gas. It is a little toxic and it's irritating, but it's not as toxic as chlorine. Small amounts of it won't hurt you, but if you breathe like concentrated hydrogen gas, it will hurt you. So just be mindful about that. And so after the hydrogen gas and the chlorine gas are done reacting, there's going to be nothing but dissolved sodium and hydroxide molecules. And then you just filter this off to get rid of all the carbon. Since the carbon is not taking part in the reaction, it's very insoluble in water. So you filter it off, and then I would suggest boiling it off, but make sure you have some type of goggles because it is eye irritant. Because if you leave it exposed to air, it will form other sodium salts, which is what you don't want. So anyway, that's what's going on right here. It's relatively easy to do, and you can do it very small scale, you can do it very large scale. And I forgot to mention, this process right here, this will go on for days. This will take days to do because there isn't that much ampage. Like what we learned in electrochemistry, ampage is everything. Amps is the volume of electrons that's going from electrode to electrode, and volts is the ability for something to produce electrons right now. So if you have an ampage machine that can take it maybe 6 amps or something like that, maybe even 10 amps, more amps the better, but just be mindful about that because too many ampage could make it go out of control. Anyway, the more ampage that you have, the faster the reaction will go, and it'll be done. This I'll probably have to let sit for maybe 3 or 4 days, get plugged in. But just make sure that if you're doing it the same way I'm doing, this chlorine electrode, you do change it every once in a while because it will get destroyed. That's why you want to have a lot of this. So anyway, that's the video here. If you have any questions, you know how to email me and all that stuff. You can also look up other videos and stuff like that. I can also do it. And also I want to mention that here you can do it with any salt that you want, magnesium sulfate, copper chloride, anything. It will always produce the metal hydroxide, and whatever the other part is, it'll probably produce that gas or some type of acid. So like magnesium sulfate, if you put it in here and you do this process, it will produce magnesium hydroxide and sulfuric acid. So just be mindful about what you put in here. I would suggest putting sodium carbonate in here because it is a lot safer because it gives off water and carbon dioxide gas. You can get that from taking sodium bicarbonate and making it, like boiling it. That'll boil off all the water and carbon dioxide, and you can use this for this process because it's a lot safer. So anyway, I know this was a long video. I apologize for the quality. I hope you guys all stay safe and stay healthy during this time. If you have any questions, please do not hesitate to email me. Thanks guys. Bye.